Mark Davis. I'm the CEO and one of the founders at Virsto Software. I know some of you guys, but not all you guys. Hi, Howard. Look forward to make sure we all connect up in person later. Thank you all for coming to Virsto Software and meeting with us today. We've been building product that is specifically designed to solve the problems of storage and virtual machine environments for a few years here at Virsto. Today what we're going to do is give you a deeper understanding of what we do as a company, where we come from, what our technology is. We're going to give you a little bit of secret future stuff, some things that we're working on that's pretty exciting stuff as well. And we're going to show you some demonstrations of our software. We'd love to interact with you and hear feedback. We're really excited to have you guys all here, so I want to thank you all for coming, and thank you, Steve and company, for making this all arrange. So really quickly, I'm going to give you a quick overview of the company. Linda, would you mind clicking? So just to understand who we are, we, as a company, my co-founders and I, Alex Marashchenko and Serge Pashenkov, started in 2007 talking to customers who were doing significant deployments of VMware back in those days. And back in those days, you could count those people on your fingers and toes. That was really, it seems like a long time ago, but there weren't that many big deployments back in those days. We went and talked to them, and what we found out was that every time you talked to a customer who was doing a significant VMware deployment, and back in those days it was a few hundred servers, was giant. Everybody said, boy, virtualization's lovely, we love it to death, but gosh, storage is a real pain in the neck. I'm using traditional ways of solving storage problems in a virtual machine environment, and it's all sort of broken. And that's what gave us the inspiration to start the company and go figure out how can we solve the storage problems that are uniquely caused by the existence of hypervisor-based computing. We did not know what to call what we were doing back then. It was a totally new idea, and we had all kinds of things we used to try to explain what we're doing. We would talk to customers about how we're building this thing that's kind of like a clustered file system, but it's kind of not. It's kind of like a clustered volume manager, but it's kind of not. It kind of works in this environment, but it kind of doesn't work in this way. What we were doing was so different, it was hard to explain it to people. And one of the words that we used back in the really, really early days was actually suggested to us by an industry analyst. He said, you're sort of like a storage hypervisor. And he said, but that's too long of a name, you can't call it that. Call it a storage visor. So I tried that in my early VC pitches, where we were making this thing, we're going to call it a storage visor, and nobody liked the term. So we stopped using that term. And it's funny because about 4 years later, people started using the term storage hypervisor again, and we said, aha, we've heard those words before. If people are going to understand what that means, we can start using that to describe what we do. So in the last about year, a lot of people in the computing industry have started talking about this concept of a storage hypervisor, which is really what we've been building here for a while. Then another funny thing happened along the way, which is in June or July of this year, our friends at VMware in Palo Alto, California, spent a little over $1.2 billion buying a company that nobody's ever heard of, called Nicira, which built this software.
Some of us have heard of it, but
a few. Maybe this room is sort of rarefied, but let's just say the general public had never heard of this company that was doing less than $10 million a year in revenue and got bought for $1.2 billion because they solved this problem called software-defined networking. And all of a sudden, VMware started saying, you know what? It's software-defined everything. Software-defined data center. We have software-defined servers. That's what VMware's been building for a while, right? And that's what Hyper-V is. That's what Zen is. Now we've really dove into the software-defined networking in a big way. Everybody knows the next big thing is software-defined storage. So we use this term software-defined storage here at Virsto. We've been talking about this for a very long time. Most of the market hasn't. So we're really glad we got in front of this problem, because now there's an awful lot of visibility and understanding in the marketplace of what this whole software-defined storage problem is and why we need, for storage, something very similar to what we have for servers. There's a lot of great things that little magical thing called a server hypervisor has done for us. That abstraction of the physical computing resources from the virtual computing resources has created an awful lot of magic in the industry, and a company that's worth $40 billion and, frankly, completely transformed the server industry. The most important server company in the world today does not make servers. VMware is by far the most important server company in the world, and you can't buy a server from them.
They're also by far the #1 storage company.
That's a little hidden secret, but I think we all know that, right? So there's a lot of things that we have done for servers that we need to do a little bit better job on storage. And storage is behind the server industry in doing this sort of the right kinds of virtualization. That's what we're about. We're going to talk about our take on it here at Virsto Software. We do what we call what we build a storage hypervisor. The market's pretty big. It's very easy to find a $10 billion market for what we do. There are about 11 million servers shipped per year. If someone would give you, I don't know, $1,000 per server for software to solve this problem, that's $10 billion. I can tell you here at Virsto Software, we get a lot more than $1,000 per server for our software. So we do know it's possible to build a very large market for this, which is why it's very exciting to people. As a company, we're growing super fast. At Virsto, things have really taken off. We build products for both VMware vSphere as well as Microsoft Hyper-V. The core technology that we'll show you today, I don't know if our demos are going to be on Hyper-V or VMware, but the things that our software does are universal. They work on both platforms equally well. The way you see it as a user is different. In a VMware world, you see it in a way that looks like vSphere, and in a Hyper-V world, you see it in a way what looks like System Center. And by the way, our software does run on other platforms. We have not productized it, but there are other virtualization platforms in the world, and our software does know how to talk to them. And someday, we will probably turn those into real products, but for now, we do Hyper-V and VMware as production products. We've been deploying our product with customers since 2009 on Hyper-V for about the last year, a little less than a year on VMware. We've got about 80 customers that are paying customers to date that have been running this stuff in production for a while, so our code is pretty proven. What you'll see when you learn more about our software today is there's a lot to it. This is a non-trivial problem. This is not a lightweight piece of software. This is very much rewiring the infrastructure of the way I/O works in a virtual machine environment, and it's very, very hard to get this stuff right. Any of you who've been around large complex system development in your life and dealt with things like clustered file systems and clustered volume manager and clustered storage systems can tell you that it takes a few years to get software like this to work properly in all the many corner cases that happen. So we've been at this for a while with some pretty significant intellectual property. We have got to put together a really great team of people. Most of our team is here in Silicon Valley. We also have a good-sized contingent in Melbourne, Australia, that does a good deal of our development for the VMware platform. And we've got a few salespeople scattered, but the core of the team is between here and Melbourne, the R&D team. We have been expanding our sales force pretty aggressively, but we're still pretty thin, frankly, on the sales front. We are right now about 50 employees. We're growing very rapidly. We grew 50% in the last quarter in our headcount, and we probably will continue to grow at a pretty fast rate because of the demand for what we're doing is pretty high right now. So that's where as a company. Next slide, please, Linda. Just really quickly, I just hope you guys all get this and we don't have to explain it to you, but you guys all know that the way traditional storage systems work with virtual machines just frankly sucks. I put not all on the slide, but it just sucks. It's bad. No one would have designed a storage architecture the way we do it today from scratch if they had done it in a post-VMware world, right? If you knew from scratch that you were going to have these things called hypervisors and everybody was going to use them and you were going to run multiple OSs on all your servers all the time, and by the way, you're going to be moving those virtual machines, those operating systems around from server to server while the apps are running all the time, and you might be moving them between data centers all the time. If you knew all that stuff, you would not build the kind of storage systems that we all implement today. You just wouldn't.
Sounds like Steve. Yeah, I think I said exactly that.
Did you?
Tuesday. I totally agree with you.
Okay. Well, thank you.
Right there with you, buddy.
Thank you, Stephen. Yeah, because there are some assumptions. So I've sadly been in the storage industry for a very, very long time. And most of my team have been as well. There are a lot of assumptions that we have built into the entire storage stack, literally from the disk drive up. Anyone knows how disk drive controllers work? There's an amazing amount of virtualization software in every disk drive you guys have in your laptop. Forget all the layers above. The things we put in HBAs, in switches, in NICs drivers, in the both client-side and server-side HBA drivers, in the volume manager, in the file system, in the database. There's a huge amount of software that is trying its hardest to optimize the way applications talk to underlying storage, how they manage the flow of IOs, how they order them, how they do queuing, all this stuff. And the assumption that's built into all of that software is that the operating system is controlling the hardware that it's talking to, which, of course, is completely what virtualization breaks. Because what does a hypervisor do? It lies to operating systems. That's what they do. Hypervisors tell operating systems that they control hardware that does not exist. Or they tell them they have exclusive control of hardware that they, in fact, might have a little slice of, but they actually don't have exclusive control to. So a lot of the assumptions that work great in physical computing get completely broken by virtualization. And it causes a lot of problems. The three big problems, or big categories of problems, are around performance, around space utilization, and about operational efficiency. Performance of storage in a virtual machine environment can be dramatically negatively impacted because once we have lots of operating systems trying to talk through a single piece of hardware, through a single set of interfaces, through a hypervisor, to back-end storage, what we have is all the optimized I/O flows and queuing management systems and all this other elevator algorithms and all these things we do in the software stacks in the server are completely broken because the hypervisor is going to take all those I/O streams from all those servers, jumble it up together, multiplex it together, and spit it out the back end to whoever the storage is on the back end, who's going to see a ridiculously randomized set of I/Os. And for anybody who knows how the way storage works, random I/O is always slower than sequential I/O. It's just a fact of physics. It's a really big fact of physics with rotating disks, but it's even true with Flash. Flash systems can do random writes not that well. They can do sequential writes really well. They can do random and sequential reads really well. Small random writes are not Flash's friends if you know the physics of the way Flash works. So a system that generates a lot of random writes, even if it's to Flash, is going to be severely performance degraded. We call that the I/O blender. We also have the problems of capacity wastage. In the virtual machine world, we build servers. We make virtual machines all the time. Right-click on a menu, say make me a new VM. Voila, I've got a new VM. When I do that, I am basically replicating a VMDK or a set of VMDKs. And what is a VMDK? It's a very big file that happens to have an entire copy of Linux or Windows or your operating system and all this other stuff in it. And I do this all day long, 7 days a week. I make gobs of these, and they all have the same stuff in them. If I've got 1,000 virtual machines, I've got 1,000 copies of Windows. And that was painful in physical computing world to have all this extra replication, but in virtual machine world, we simply make more. We have a customer that we are just sold some software to who was sure they had control of their virtual machine environment, really sure. We went into their environment in June, July, did a bunch of measurements, amongst other things, found out they had 6 virtual machines. We just went back in and talked to them last month. They had nearly 1,000. We went and told the IT director. He thought we were lying. And we said, no, actually, you really have 1,000 virtual machines. You really did grow your virtual machine presence by 67% in 3 months. That sprawl is going to cause a lot of space wastage problems because every time you do that, you're going to replicate the data. That's unnecessary. Pardon me. And the other thing is, in the virtual machine world, because of the magic of what a hypervisor does, when you're a virtual machine administrator, you have to be a storage administrator. It's not avoidable. Why? Because of the magic of virtualization. Because again, what is a virtual machine? It's just a big file. You make a virtual machine, you got to make one of those big files. You have to make a VMDK. So you cannot make a virtual machine without provisioning storage. It is part of the process of making virtual machines. And you can't destroy and reclaim a virtual machine, retire one, without also retiring the storage. So you cannot separate the storage provisioning process from the virtual machine provisioning process. You could try to make it asynchronous by pre-provisioning a whole bunch of storage and letting your storage guys take it, which is what we all do today. Again, not optimal, but you can make that work. We make a big honkin' VMFS data store, and then we just allocate storage out of it. But we still have this problem that there's a big impedance mismatch between the speed of server provisioning and the speed of storage provisioning. I don't care what storage array you buy today. Storage arrays don't like to get provisioned 10, 15 times a day. It ain't the way storage provisioning works. You know, you don't want to be making LUNs and metas and carving off all these things that often for all kinds of reasons. So we usually try to limit the frequency with which we provision storage. At the same time, we're provisioning servers all the time. That impedance mismatch between the provisioning of these two things is a real problem because in a virtual machine world, again, when you make a virtual machine, you have to provision storage because it's what a virtual machine is. So we have to think differently about the workflow. The entire life cycle of these storage objects in a virtual machine world, these VMDKs, or in the case of Zen or Hyper-V, these VHDs, it's an entirely different life cycle than your average storage LUN. And we need to build systems that are around that idea, and that's what we built here at Virsto Software. I'm giving you this background so you can understand sort of what inspired us to do the product that you're going to see demoed today. Okay, next slide, Linda. So there's lots of ways to solve this problem. So there's always, buying more storage arrays, and I will tell you, most customers we deal with today, how are they going to solve the storage problems they have in their virtual machine environment? They're going to buy some more storage. Typically, in big environments, you find that storage is about triple over provisioned. So they needed X amount of storage, but they bought 3 times as much because that's the way they got enough spindles, they got enough cache, they got enough I/O channels to get the throughput that they needed. And while that's okay, I think there's a funny irony behind that, right? We all went to virtualization so we could use our servers vastly more efficiently, right? We can actually use all those CPU cycles, all that memory bandwidth we have in our servers. And in order to do that, we are using our storage even less efficiently than we used to. And that's a crazy little irony. And by the way, in order to do that, we've got to buy some pretty high-end storage systems, to solve the performance problem. There's a whole bunch of guys building new storage hardware, and some of them are really cool. Some of you guys probably met with this week, I'm guessing. I don't know who you guys met with, but some of these guys maybe were on your trip here to Silicon Valley. Cool stuff, really cool stuff, particularly all the flash-based guys. They do solve some interesting problems. Just like Intel, and when the server guys build greater server hardware, it's a good thing. At the same time, you still need the right kind of software to make this software-defined data center work. So we look at the people that are building these different kinds of storage arrays as partners and as people that we can add value to. But let me go forward one slide here, Linda. Let me just talk about the software-defined part of this. So I stole this slide from VMware, who's obviously talking about, this is their, for those of you who are at VMworld in August, September this year, again, right after the Nicira acquisition, everything was software-defined, fill in the blank. So again, we've got pretty good answers on 2 of these 3. Click one more for me. The weak link in this whole thing is clearly storage, and everybody knows it. We sort of got software-defined storage, but it's not really what it needs to be. The networking thing is sort of getting solved. VMware just made a $1.2 billion bet to solve it. The server side is pretty well done, right? There's still more things to be done to server hypervisors. They're pretty good. The storage stuff is pretty weak. Not because we don't have gobs of storage software. It's because it's not configured in a way to make these resources aggregated, pooled, and flexible in the way we want to. And that's what we do here at Virsto. Next slide. You guys can read this. So what does software-defined storage mean to us? What did Alex and Serge and I think about in 2007 when we were in Serge's garage trying to invent a company? Was how do we match the data requirements with storage capabilities? That's what it's really all about. Storage guys like to talk about storage, and we often confuse data from storage. Just as we in the server world, we're trying to match the computing requirements to the underlying server hardware, and that's what the VMware products and the Hyper-V products and the Xen products allow us to do is you connect the supply and the demand in a way that's fluid, that's fungible, that's efficient, and it's commoditized. We're trying to do the same thing with storage. That's what we're all about here at Virsto. Next. So the argument I want to make to you guys, this is also a slide I stole from VMware, for those of you who are also at VMworld, is that there's a whole bunch of things you need here. There's a lot of orchestration, there's a lot of instrumentation that has to happen, things like DRS and SIOC, if you guys know the VMware buzzwords. There's lots of things that have to get done. But in order to achieve this notion of a software-defined, highly efficient data center for storage, it's the data services that matter. It's our ability to move data around in a way that's flexible and fungible and that's independent of the underlying hardware, and do it in a way that doesn't unnecessarily replicate bits. So things like the right kind of caching, the right kind of replication, snapshots, cloning, encryption, dedupe, all these data services are very fundamental to this. And as we all know, lots of storage hardware systems can do that today, and that's all goodness. But we also have to have a way to do that in software and control it by software, which is what VMware and others are talking about, okay? So let's just double click on that a little bit. So, thank you. So here's the problem. Oh, this slide isn't very clear, sorry. I will try to walk this through this. So here's the problem. So this is, I'm not picking on VMware here, by the way. I could do, this happens to be a VMFS 5 performance chart that I'll explain to you in a minute. We can make the same chart on Xen. We can make the same chart on Hyper-V. This is inherent in the way hypervisors work and inherent in the way the current generation of storage software that work in these environments performs. So this is a chart showing 2 things. One is IOs per second, which are these 2 lines here, which start pretty high and go down, and read and write latency in milliseconds. And the horizontal axis here is number of snapshots and number of clones. So we all know that there are snapshotting features built in this example of VMFS. Again, I'm not picking on VMware. This is true of all the hypervisors. everybody knows there are snapshot and cloning features that are very space efficient that that people use. But everybody also knows who uses these things in production is that when you try to use these data services, performance goes down. So you sort of have this trade-off. I can either be space efficient or I can be fast, but I can't be both. This is an example of that. So with no snapshots, we get pretty good performance. This is read and this is write IOPS through a system. This is actually on a EMC VNX running vSphere 5 with VMFS 5. As you start to add snapshots, you quickly see a really fast drop off in performance, and then you quickly are sort of have this nice asymptote that's closely approaching 0. And this is why people don't take lots of snapshots. This is why everybody says, yes, there's a snapshotting feature, but don't use it very much, and certainly don't use it in production. At the same time that IOs per second go down, we see latency. When there's no snapshots, it's pretty fast. You get these nice, really fast read and write latencies. But as soon as we add snapshots, the latency goes up. This is the performance problem. We have data services, but we can't use them in production because we have to trade off performance versus space efficiency. Next slide. So here is a comparison with Virsto Software. This is roughly the same I/O per second numbers. These dashed lines here are native VMFS 5, again running on VNX. A nice size EMC VNX system. And these solid lines are what you get out of Virsto software in that same environment. So you'll note a couple of things. First of all, with no snapshots, we do get better performance sort of raw by adding our software to the system. The interesting thing is that as you add snapshots, whereas without us, you see this big performance degradation. So as you're running more and more data services, the performance goes down. With Virsto, we've got a pretty nice flat line as we're adding snapshots. This particular test goes to 6 snapshots. In our lab, we routinely make thousands of snapshots. One of the things that we believe very strongly at Virsto is there are lots of good reasons to make lots of space-efficient snapshots and clones in a virtual machine environment. For backup, for replication, for purposes of creating lots of virtual desktops. If I could just clone a virtual machine 1,000 times really fast and stand those up as 1,000 virtual desktops, that would be the ideal way to do it. Today, it's a little challenging to do that. We designed our software to do enormous numbers of these without any performance trade-offs because we believe that the data services have to be uncompromising. Next slide. I'm going to show you 2 more slides here just for fun. And this is kind of interesting if you think about the economics of the software-defined data center. So I'm going to show you, these are real numbers from 2 customers. So one customer is a transportation customer of ours that has a bunch of Oracle databases. These are tier 1 apps for this company. They also do a fair amount of internal development on Oracle, so it's a test and dev environment for them. These are the guys who didn't know it, but their stuff was growing at a compound growth rate of nearly 200% per year. And had fully admittedly over-provisioned everything. These guys run VMAX, they run VNX, they've got gobs of Clarions, they run some Dell EqualLogic, they got all kinds of storage, petabytes of this stuff that they freely admit they have 3 times as much of as they really need, but it is what they needed to do to get performance. The interesting thing here is the economics. You guys can run through the numbers of this, but they were basically, we sort of ran 2 scenarios for them. One was, you ended up with this, the total cost of servers, storage hardware, and software was about $1.1 million. We added our software. We charged them about $250,000.
Not enough. Charge them more.
It's a long story, but yes. This is actually a part of the deal we have with this customer. This is not the full deal with the customer. But in this particular subset of this deal, we saved them a couple $100,000, $250,000. But the interesting thing here, if you're thinking about the economics of the computing industry, is how the dollars shifted. So without Virsto, out of that $1.2 million, 15% of that went to software, and the other 85% went to server hardware and storage hardware. When you added Virsto software to the total number got smaller, which is what the customer likes. What we software vendors like is what happened here. Nearly half of the business went to software. And this is the kind of economic sea change that the right kind of software can cause in the industry. Just as, I was joking earlier about who is the most valuable, most important server company in the world, the one that doesn't make servers. People spend more money with VMware on software than they do on the servers that they run on. Just as in previous decades, Oracle did the same thing. People spend more on the Oracle database than they spend on anything below it in the hardware, right? People are very happy to pay for high-value software because of what it does to give them value, allow them to go to market faster, and do it at lower hardware cost. This kind of economic model applied to the storage industry, I think, is the same kind of economic model that we previously saw in the server industry, and potentially pretty disruptive. Next slide. Similar idea. I just want to show you, this was not one lucky thing. We got one customer. Similar situation with a different customer. Customer ended up saving 150 grand net with us. By the way, it isn't just saving money. It's also better performance. It's better operational benefits. So our TCO models, our value proposition to our customer, isn't just that you're going to spend less money, although that's part of it. It's also that your apps are going to go faster. You're going to have not only faster application performance, but more consistent. So instead of some of them going really fast and some of them going really slow and you're never sure which is which, you get consistent application performance with our software, and you get a much simpler administration model. So our value proposition is more than economic. But again, the interesting thing here is the percentage of the money that the customer spent on software versus hardware. And the reason why I'm showing you guys this is to help you give you a picture of how the right kind of software applied to the storage industry can change the economic landscape of an industry in the same way we saw on the server side over the last 10 or 15 years. So next slide, I think, is my last one. It's our obligatory customer. We have some. You can talk to some of them. Yes, these guys do buy our software to run inside their data centers. So although there are parts of Microsoft that will tell you that you don't need to add any software to Hyper-V to make it wonderful, I can tell you that Microsoft does, in fact, use our software.
It runs at 3 times the speed of light without anything extra.
It does, doesn't it? But with us, it's 6 times the speed of light. So anyway, it's all good stuff. We could talk more about these customers. I really encourage you guys to dig in with the engineers who are going to talk more about the product underneath. There's a lot of technology here. We want to make sure you leave here with a pretty good idea. So I thank you for your time, and I think I'm going to pass it off to Brian.